we were looking at this question where we were told that an insurance company estimated that 30% of all automobile accidents were partly caused by weather conditions, and that 20% of all automobile accidents involve bodily injury. Then we were told further those accidents that involve bodily injury, 40% were partly caused by weather conditions. We were given this question. Here we were looking at two major events, right? Where we define W to be the event that automobile incident, automobile accident, partly caused by weather conditions, partly caused by weather conditions, and we took I to be the event that automobile incident, automobile accident involved bodily injury. So you are looking at these two main events in this question, and you've already done the first three parts. I want to do part D. Part D says, what is the probability that the randomly chosen accident both was not partly caused by weather conditions and did not involve bodily injury? Essentially, what they're asking us to find, we want probability of W complement and I complement, right? This is what we want because they're saying that the randomly chosen was not partly caused and did not involve bodily injury. So we want to find the probability of the intersection of the complements, right? We want to find probability of neither W nor I. So we want to find the probability that it was not caused by weather conditions and nor did it involve bodily injury, right? So we want to find this. And this can be found as if we want to find this. So to find this, whenever we want to find the probability of neither A nor B, like this, so what we will do is we can find this as probability W complement intersection I complement is just going to be 1 minus probability W union I. Why does this work? Because this works because remember union probability W union I is the probability, this is the probability of W or I or both, right? Because, right, so when I find the probability of W union I, this is the probability of W or I or both. So this is the probability at least one of W or I occurs, right? So if I subtract this from one, we'll get the probability that neither occurs, right? Now, how do we find where how do we find this probability W union I? So we know we can find this using the inclusion exclusion principle addition rule of probability, where we know this is probability of W plus probability of I minus probability of W intersection I. Now, probability of W is given to us as 0.3. An insurance company estimates that 30% of all automobile accidents were partly caused by weather conditions. And probability of I is given to us, and 20% of all automobile accidents involve bodily injury. So this is probability of I minus, want to find the probability of W and I, which we found in part A. Find what is the probability of the randomly chosen accident was both partly caused by weather conditions and involved bodily injury. So we are going to use this from part A, right? So we already found in part A 0.08, right? So this is from part A. This is from part A. The 0.08 is from part A. And here what we applied was essentially the inclusion exclusion principle or addition rule of probability. Inclusion exclusion principle or addition rule of probability. So when we find probability of W union I, it just turns out to be 0.42. So probability of not W intersection not I is just going to be 1 minus 0.42 is 0.58. Right, so basically the whole idea over here is this. We have to find the probability of not W and not I. It's just 1 minus probability W or I, or means union, right? Because probability of W union I is the probability that W occurs or I occurs or both occurs. So it's the probability at least one of them occurs. So from 1, we subtract the probability that at least one of W or I occurs, we'll get the probability neither occurs. Here, just a thing to note is going to be here a quick warning. A warning. When you want to find probability not W intersection not I, this is not equal to 1 minus probability W and I, right? This is not correct. When you want to find probability neither W occurs nor I occurs, that's going to be 1 minus probability W or I, not 1 minus probability W and I. Why does this not work? So this is the, so we can also subtract one the probability that both occur, right? This is the probability both W and I occur, right? We subtract the probability that W or I occurs, right? The probability at least one of them occurs, as 1 minus probability W intersection I involves three probabilities, right? Number one, probability only W occurs, and I does not. Probability only I occurs and W does not. Probability both I and W don't occur. But we are only interested in three, right? So the idea is this: you cannot find probability not W and not I as 1 minus probability W and I, because from this what you're doing is from one you're subtracting the probability that both of them occur together. So when you subtract this from one, so this would involve the probability that just W occurs, the probability just I occurs, and the probability that neither of them occurs, right? But what we are interested in is something different. We're interested in only three, right? We're only interested in this, right? But this will involve these two as well, right? Because when what you're subtracting from one is the probability both W and I occurs. So this would involve the probability that only W occurs, only I occurs, and the probability that neither of them occur. So just to, so in short, if you want to find probability of not A and not B, it's going to be 1 minus probability of A union B, right? Because this is the probability neither A occurs nor B occurs. And this is the probability at least one of them occurs. So this includes the probability that only A occurs, only B occurs, or both of them occur. So when you subtract this from one, you're going to get the probability that neither of them occur. But this is equal to not equal to 1 minus probability A intersection B, right? So probability neither A nor B is 1 minus probability A union B, because this is probability at least one of A or B occurs, right? This is the probability both A and B occur simultaneously at the same time. Right, so probability neither A nor B is not 1 minus probability A and B occurs, because like we said, this involves the probability just A, just B, which we're not interested in.